Hello and welcome to PCB Chat. I'm your host, Mike Buetow. Today's podcast is sponsored by PCB West, the leading trade show for the printed circuit design and manufacturing industry, coming September 9th through 12th to the Santa Clara Convention Center. Visit PCBWest.com for details. My guest today is Mike Creeden. Mike is a veteran design engineer and training specialist with over 40 years experience in the industry. He just joined Insulectro, the materials distributor, as Technical Director of Design Education. Mike, welcome to PCB Chat.
Thank you, Mike. It's a pleasure to be here.
So let's start by discussing your background in design. I know you've worked across a broad swath of companies from CAD providers to major OEMs to EMS firms and service bureaus.
The one thing I usually tell people right from the beginning is I love PCB design. It's been a great profession for me, and I have a passion that remains to this date. I grew up in Illinois, outside the Chicago area, and started working there and kind of have never looked back. Started doing electronic circuits for resistance welding controls out of Detroit. Eventually moved to the West Coast. From there, worked for Western Digital. I did some IC layout there, which actually was a good building block in my career because they tend to work in cells there in that space, and I really enjoyed it. I had the opportunity to travel across the country, moved to Cleveland, Ohio for 4 years, and then to the East Coast of Boston for 4 years. Worked for Prime Computer, and I worked for Johnson & Johnson making the CAT scanners and the first development of those type of large-scale scanners, MRI scanners. Then moved back to San Diego. San Diego has been home now for the past 30 years. And as you'd mentioned, I've worked for a handful of OEMs, some of the large OEMs like Intel, Cirrus Logic. I've also worked for the CAD companies. As you had mentioned, I've worked for Zuken, for PADS, and I've also worked for Creeden during the acquisition when they first acquired Allegro and ASI. And so after that, I worked, and I kind of got tired of going to other companies, so I started my own company, San Diego PCB Design Incorporated. Was the founder of that, ran that for about 15 years, and I had the opportunity to sell that 3 years ago to a company called Milwaukee Electronics and Screaming Circuits. I've been supporting them since then as they've transitioned to the new owners. This year, I had the opportunity to take a position with Insulectro. So there's the overview of my history.
So let's concentrate on San Diego PCB design for a moment. I believe that you were doing layout work and you were doing some training there, correct?
Correct. I've always been a designer, so although as the owner, I was a functional designer at the same time, and as we were building a staff, we've always believed that, you hire good talent and you also build good talent. And so that built a team, so there was a team approach to that. I had the opportunity early on in my career to actually write a couple of curriculums for PCB design. I helped to bring the PCB design course in at Palomar College, and then also when I lived in the East Coast at Roxbury Community College, I brought in a psych-arts class there where I wrote the curriculum and I taught it. So did that for about 2.5 years there, 3 semesters. So I got a passion for education, and I was approached by Gary Ferrari to, I had taken my CID and my CID Plus. Gary Ferrari suggested, Mike, maybe you could become a CID trainer. And so about 6 years ago, I did just that. Got certified to teach the CID, then later got certified to teach the CID Plus. Then Gary suggested that I become a part of the team to rewrite the CID Plus curriculum. And so with Gary, Rick Hartley, and several other people involved in that, Sherry Liston was a major contributor to that also. We rewrote the CID Plus. then became what is known as a master trainer, an MIT. That's an IPC designation. And I do that through the company of EPTAC. EPTAC is an IPC licensed trainer for North America. And they do some training in foreign countries also, but I think they're one of the premier trainers in North America. And I think they're the only licensed one to teach the CID and CID Plus in America.
How do you describe the difference in training students that are at the college level versus folks who've been in the industry for perhaps several years?
Great question, Mike. So the CID program by creation was meant to take an existing designer, someone who was already performing the design task in industry, and teach them about manufacturability. That would be the CID basic class. And then the CID plus class taught them more of an advanced construct of design for performance. They taught them about EMI, signal integrity, and some advanced constructs in manufacturing, such as HDI. So again, teaching an existing designer about the design for performance or design for manufacturability. In contrast, the college courses were more of an exposure. Let me expose you to what the profession does. And I use the word exposure because it's in my opinion that many classes just want to expose someone to PCB design. You can't teach in 30 or 40 hours a profession, okay? The profession of design layout is an apprentice and journeyman type trade. Just as you might have an electrician, a plumber, a mechanic, those are what they call the trades. And those trades, you serve for 2 years as an apprentice with a mentor, and then you would go another 2 years as a journeyman, where you're given actually senior tasks, but you're overseen. And then after that, you become a tradesman. That's normally how the profession has evolved. It's actually in a little bit of a peril at this point because they're not bringing new people in. And so that's another discussion.
We see more degreed engineers walking the corridors of PCB West today than ever. I think that we're seeing that evolution to design being not just the career of somebody who explicitly does layout, placement, routing, that sort of thing, to folks who are tasked with other engineering responsibilities and then also do layout as a portion of their job. Would you say that you're seeing the same trend?
Absolutely. As a CID instructor, we always will do a survey of those people taking the class, and we ask, what is your background? Are you a designer taking this course, or are you a new engineer? And we see the exact same thing. The majority of my students now has evolved, and they're engineers. They're double E's, and most of them have been conscripted to do layout simply because there's layout people are retiring. You look at the survey, the salary surveys that your firm produces, it shows that the transitioning out of the workforce, the graying of the PCB design layout engineer is occurring. And so they're conscripting engineers to do it. So the question always is, are those engineers prepared to do it? Do they have a knowledge base, and would they have competency? I've never met an engineer that'll say, no, I can't do that. By nature, an engineer is a get-or-done type of person. They're problem solvers. But the point that I would like to make is that industry has not addressed this concern, and there are no courses being taught to those double E's. They're just thinking because you're a double E, therefore you can do a layout. And they've given them no training. You go to almost any university that exists, there are no curriculum for it. So they come out and they're desperate for information. That's why you see them attending all the professional development courses. I see them in the CID classes. They're scrambling to get it. Now, Rick Hartley always, when he speaks as a professional development instructor, always asks the attendees, who does layout? And then over here, who does engineering, draws the schematic. And then he says, who does both? And those people that raise their hand and say, we do both, he says, I'm going to ask you a question, and I want an honest answer. Which of the two disciplines do you find more difficult to perform? And categorically, almost 99%, 98%, pick a number, will say doing the layout is more difficult. And it's challenging because I've not been prepared, yet my company has this expectation to do this.
Well, that brings us to the Insulectro Design and Education program. Who is that program aimed at, and what exactly does it entail, Mike?
Well, I appreciate you asking that. It's an observance. It's geared as an observance to, let's just say, the lack in the industry of both knowledge base and competency. There is a seeming void, and so we're doing our part to fill that. And when I saw Insulectro's, let's say, passion to do this and determination to make this a success, it was what attracted me to this, okay? With an impending shortage happening in the design ranks and engineers being conscripted to do this, we want to help prepare them. So it is our goal to truly help plug them in with existing design service centers that are out there, should they need overflow. If they have a design staff, it's our goal to help be a education or information place where they can go to. Insulectro is not, I repeat, is not in the business of doing design services. Our goal is to put them in touch with professional companies that are, if they have the need. We are eager to do design reviews to help people design and build a functioning and performing circuit. And with that, we understand that materials matter. Okay, with circuitry advancing with the technologies of today, from HDI to high-speed design to power delivery systems, the high power stuff for the either downhole market segments or the under the hood automotive segments or power drive segments of EV space. The materials all are now basically designed to meet performance requirements for those circuits. And so designing a circuit has three challenges. The IPC Designers Council Executive Board actually wrote a professional description for layout, and it describes these three design fours. If I say DFM, that's the common one everyone understands, designing for manufacturability. Now, that would mean a fabricator, an assembler. It would mean test, reliability, compliance. Those are all the manufacturing section. The other thing is solvability, design for solvability. This is solving an HDI with a micro BGA with micro traces, that are in the 25 micron or above type of traces. This is a solvability issue. It's a packaging science. The third thing is the design for performance. This is high speed. The switching speeds by which a rise time is going to get all of its energy is now in the sub-nanosecond range. And some of it is faster than the nanosecond. It's way getting down into the picoseconds. Therefore, every bit of performance matters. And the energy does not travel on the traces. It exists in the material. So the traces we route, everyone sees the traces and thinks that's the energy. No, it is basically a waveguide whereby the material is the host to the energy field, both electro and magnetic. So EM, electromagnetic.
I'm glad you brought that up, Mike, because as materials have gotten more exotic, more complex, and the fabrication and especially the reflow processes that they undergo have become more extreme, we certainly see more attention needed on what I'd call the recipe almost. And, we've moved away from simply plugging in FR4, as you know, to all sorts of different flavors. Mm-hmm. Fortunately, I guess from your vantage point, Insulectro supplies a lot of that, but designers need to stay up to speed on all that. And I suspect that's going to be one of the things that you work with them on. I know that Lee Ritchie, who's speaking at PCB West next month, spends quite a bit of time on materials because if we're talking about the dielectric, you can't escape that conversation.
Agreed. So when you think of materials, it depends who you're speaking to. If you're speaking to the fabricator, their challenge is to find a material that is suits the process that they have, and therefore there's different process performance levels. When you consider drilling, some materials are just not good for drilling because of the weave that's in there or the dimensional stability. The other thing is a physical property from the manufacturing process. When will the material basically transition from a solid state to a rubbery or gelatinous type state? And therefore the resin starts to move, okay? Now, the other thing you'd want to think about is when can I overheat the material where the material actually will decompose, okay? That's the T sub D, which is the decomposition of the material. And then what materials work with other materials? There's a compatibility factor because so many designs nowadays, based on the solvability, I alluded to that earlier, require very sophisticated stack-ups. 20 years ago, it was a 12-layer board was considered kind of high-end but standard. Nowadays, we're seeing 30 layers and more. Whenever you throw out a number like that, someone goes, well, I do a 40-layer, There's not much ceiling to what technology, how it advances. And so another factor is the drilling. Drilling is probably the hardest challenge that a fabricator needs to solve. It's the plating into holes, the drilling, the aspect ratio, the plating wall thickness, and then the dimensional stability of the material in contrast to that plating creates via failures. And so there's all kinds of testing to substantiate that for reliability. And some fabricators have better equipment than others when it comes to that. But those are the challenges that from just a physical standpoint. And so one of the materials that we're seeing great momentum in the industry is what's known as the sintered paste. Ormet, one of the manufacturers of that, it's a trade name for that. But essentially, you're just putting in a paste, a conductive paste in the via holes, and then you can laminate all these layers together, and you don't have to do the plating. So that is a great advancement. It also solves a design for solvability. It addresses that. So those are just the physical aspects that the material in the process, manufacturing process, have to solve. Back to what I said earlier is the performance of the material. There's literally so many different market segments, from RF to the high-speed digital. All you always have to say is the word 5G, and, everyone's ears perk up a little bit because this is coming. Within this year, it's coming. And the 5G technologies will, basically arrive at three different, let's just say, bandwidths, if you would. The 40 gigahertz or below, and somewhere on 76 and below, and then 76 and above. There's two things there. There's a gigahertz, which is a frequency, and gigabit, which is a data transfer. And so there's two measurements to that. Typically, the data transfer is a send and receive, so it's usually 2x type of a factor. But the speeds are radically different than what we have seen in the past. And therefore, not just the material and the dielectric performance, but even the copper itself. Most of all of our circuitry is done with copper. And copper has a smooth side and a rough side. The rough side of the copper gives you adhesion and it gives you peel strength. It allows the material for any rework, or it avoids delamination, stuff like that, where the metal would come off the surface. So that's a good thing from a manufacturing process. But from a performance standpoint, the the teeth of that metal is kind of like riding a roller coaster for the electrical field. And it actually can add sometimes, up to 0.1 or 0.2 dB of loss per inch. Pick a number. I'm kind of giving you general swag on those numbers. But RF engineers are fighting that loss. So they want material both in the laminate and in the copper that has low loss. So that's a low profile copper is very significant. There's other advanced materials that are coming out too, because connectors, the term is they're parasitic, meaning that energy would be lost on a connector. And that's how, board-to-board communication exists. So the industry is moving towards flex design. And these are not your simple 1 or 2 layer flexes. These are multi-layer flex circuits that have to deal with either high power, high temperature, or high speed type circuitry. And you're seeing DuPont has this very broad line of materials out there that can do anything from in the power segment. There's a product called Intera, which is a buried capacitance material that truly can solve most of the power challenges that exist out there today. You never say everyone, you always say most power challenges because there's always a new challenge. There's other stuff too that, is the standard material. Their Pyrolex AP, it's like an industry standard. It is truly the most reliable material in the flex space that's out there today. And they even have a new low-cost version of that called the Pyrolex AG, which, when you start building more for higher quantities, you want to move towards like the Pyrolex AG just for that price point. They have a high-temp one, which is a Pyrolex HT. So there's a lot of different materials, I guess is what I'm saying. And our education is to truly educate and help them make the correct selection. The other aspect of that, too, is to make that selection early in the design phase from either the FR4 laminates or the DuPont laminate. Historically, the industry has just addressed this in the last week of a design or the last days of a design. And you can't do that anymore. The paradigm must shift whereby you're specifying the materials on day one and locking in a PO to your fabricator so that the fabricator can give you engineering resources to help you solve the manufacturing process allowance issues that they'll face and make sure that the material is on hand. Insulectro does pride itself in getting the materials quickly to the fabricators, but when they're given, 1 or 2 days notice, the challenge, let's just say, is significantly higher.
So that's a lot of ground to cover, Mike, and I know there's a lot of designers and engineers out there. Are you a one-man band, or will you have some help?
Great question. And no, I am not a one-man band. It's why you never do 2 shows a night. So we do have application engineers all across the country. Insulectro has 10 facilities across the nation, and it is staffed with field applications engineers. And it's also why we are partnering with design service centers across the nation. San Diego PCB, my former company, is partnering with Insulectro. Freedom CAD is partnering with Insulectro. And we're open to working with any design service center that's out there. Our goal is to make sure that those designers are equipped with the material information and can coach them on, all these 3 designed for solvability, performance, and manufacturability. So again, it's our goal to just partner with the design services. We're not in the design service business. We're not exclusive to any one of them, nor do we have any financial gain in that. We're manufacturing and design service neutral.
Well, congratulations on the latest chapter to your career, Mike. And for listeners who might want to be interested in a little bit of trivia, so Mike grew up in Glen Ellen, Illinois, and there were, I believe, 2 classic pop culture movies filmed on the campus of the local high school. Can you name them, Mike?
Well, there was Rudy was one of them, and you named the other one. Go ahead.
Lucas.
Lucas, there we go. It's Glenbard West is an iconic building set right on a lake, which I grew up skating on that lake, and I did some community village theater at the boathouse there. But it's an old castle-style building, so it's very iconic. If you get the chance to visit Glen Ellen, it's about 25 miles west of downtown Chicago. Very picturesque.
Great. Well, thanks for joining us, Mike. Good luck.
My pleasure. Thank you for your time, and thank you for all your efforts at PCB West. It truly, from my opinion and my observation, is the first-class show for the PCB design industry. I really encourage everyone to go out and attend it, walk the floor, meet the different vendors that service you, and also get signed up for the professional development courses there. You truly can get some education. I know the instructors there, and it's of great value. So get your justification pen out and convince your management to send you.
Well, thanks for that plug. You just saved me the closing plug.
Well, if I missed a spot, please add it. But I'm speaking from the heart because I really believe in that show. I've attended it for a long time.
Well, I love your passion, and I appreciate the support, Mike. This has been Mike Buetow for PCB Chat. Have a nice day.